And we are live. Hello, hello. I hope you can hear me. You can give me a thumbs up, thumbs down if you're hearing me or maybe there's some issue. I hope you will chat with me a little bit more than just silent and cricket noises on the chat that I currently there. This is AWS Maniac. Wojciech here. Today's topic is EventBridge. We'll talk about very interesting service that is especially important when you will think about serverless architecture and integration with third parties and stuff like that. So hopefully you'll share my joy and excitement about this particular service. Quick recap what we are doing here. We are in the middle of the AWS Messaging Services series. So we talked about Amazon SNS, Amazon SQS, Amazon MQ, and Amazon Kinesis data streams. That was the last week episode. And today we talk about EventBridge, and the next week I am planning to talk about managed streaming for Kafka, so manage Apache Kafka on AWS. Then we will talk about IoT Message Broker, AWS AppSync, Amazon Pinpoint, and last but not least, signaling channels from Amazon Kinesis Video Stream Suite. So that's the roadmap for this series, and we will talk about all those services in details later. I haven't planned them yet, but obviously they will be announced for every Tuesday at 8 p.m. Central European Summertime. So hopefully I will see all of you over the next month, a little bit more than a month on those events. Additionally, a small recap why we are doing this and what's the goal. It is a live streaming format, so I'm counting on your active participation. At the moment, only Andrzej said hi on the chat, so I see there are many more people available in the chat. So say hi as well, ask questions, participate. I count on you. My goal is to present all those services as a deep dives. So we are starting from zero, and at the end of the session, you should have a lot of knowledge about this particular service. My goal is to highlight the proper use cases and differences between those services. And I also additionally challenge myself to teach you about things you probably didn't heard about or you didn't know that they existed in the first place regarding this particular service. So that's the goal. If you are speaking Polish and you are not fluent in English, feel free to ask questions in Polish as well. I will translate them and answer as well. So don't worry about the English. But English is also welcome as well. Okay, cool. So let's start with today's episode. As I said, the main theme for the episode is Amazon EventBridge. And the best tagline for this service, the elevator pitch, is the statement called Serverless Event Bus. And we will talk in more what the Event Bus is and why is it serverless and why is it important for serverless architectures. But first things first, let's do an overview, a 10,000 level overview of the EventBridge. On the left hand side, you can see the EventBridge logo. And as I said, it's basically a serverless event bus service that allows you to connect multiple services and your applications with and send data between those applications from a variety of sources. Formerly, and some of you may actually remember this service, in the past it was called Amazon CloudWatch Events, and you can still see the reminiscence of this service. In many places it's actually still called CloudWatch Events. But more or less, EventBridge will be a service that will supersede the CloudWatch events. The main goal for EventBridge is to deliver a real-time stream of data from the event sources, and you can define also routing rules that will able to filter and send the those events to a particular targets. Additionally, you can also transform the data that it's routed between those targets and sources. So it's really interesting and powerful service when it comes to the delegation. Also, it supports integration with AWS related services and has Schema Registry, which is particularly useful and interesting if you will think about it, because the Schema Registry is often something that you are have anyway out of band, for example, in your code repository like Apache Drift or Apache Avro and so on and so on. Here you get something that it's built into the service and has you have ability to generate code based on that schema or to validate it and incoming events based on that schema as well. At the moment, Amazon EventBridge has built-in 90 event sources and 15 targets, and those 90 event sources and targets are only the AWS services. But it doesn't mean that you can connect only AWS services and generated event sources as well, because those 90 event sources is not about 90 services on the AWS side, but also partners. Additionally, you can have custom event buses and send your own information on events over those event buses. So your application can use Amazon EventBridge as a centralized microservice bus. And we will talk about this pattern later on as well. So first things first, let's talk about the definitions and what are the terms and definitions used inside the EventBridge. As usually, I split the presentation in 3 parts. First, we'll talk about the architecture, how does it work, what are the building blocks, what are the integrations and use cases. Then we will talk about operations and covered stuff like high availability, scalability, pricing, and security. Last but not least, we'll talk about best practices. So how to choose between various services that we described so far, how to use properly Schema Registry, how to exchange events between AWS accounts, because that's a super important feature that EventBridge is capable of. And last but not least, we will talk about the centralized event bus pattern. So let's start with the architecture, and as usually before we start, a small disclaimer. As always, when we talk about non-open source technology, EventBridge is not open source technology as well. When AWS covers the technical aspects, we are safe, but in some cases we have areas that are gray and we use educated guesses. I will mention that during the presentation. You have been warned. Let's talk about architecture. When it comes to the high level, the main goal of EventBridge is to integrate sources with targets over the event buses. And first things first, that is available and screams actually from that image, is that we've got different event buses and different purpose for those event buses. So we've got partner event bus, we've got custom event bus, and default event bus. And those 3 event buses are pretty important because default ones are dedicated for AWS services. Custom event buses are dedicated for our own applications, and we can create as many as we want. Obviously, we can be limited, but this limit can be increased based on our service quotas. Still, we can create as many custom event buses as we want. Last but not least, we've got partner event bus, which is pretty interesting because we can integrate other software as a service applications that are available, for example, in the marketplace, and other vendors that are integrating with AWS over those event buses. When we have events that are posted on those buses, we can then apply some rules to them to filter and send events to particular targets. And one of those targets that is available is AWS Lambda, can be Kinesis Data Firehose, SNS, and other additional targets that we will talk about later. So on the high level, this looks like a typical integrational / application integration / Event Bus pattern service. What is so unique for this particular service is that it's fully managed and it contains schema registry inside, which allows for schema discovery and also generating code bindings, and also introducing additional schemas from your own applications. So let's talk about the building blocks. And first things first, we need to talk about what the Event Bus really is. More or less, as we usually explain that during our sessions about messaging and queuing services available in AWS, it's usually about separating components between each other. So that's basically the case here. We allow different components to talk without knowing about each other. So that's why we use Event Bus, to separate concerns between data producer side and then the data consumer side. An Event Bus receives events, and the most important thing regarding EventBridge is that you don't have to maintain anything. There's almost no operations related with EventBridge, and you don't have to provision any additional infrastructure. It's a fully managed service. As you may think, on the event buses, we put events, which is an indication and change in environment. Any associations with domain-driven design, with event storming, with event sourcing are appropriate because those techniques are actually basing on the same thing. In other words, an event is a situation that occurs in a business process, which is often phrased in a past tense. So something that already happened. This event and this change in environment can be change in AWS environment, change in the software as a service partner service, or any change that happens in your applications, because you can also send your own custom application or services, custom events from your applications and services. When we publish events to Event Bus, before we send them to the targets, we can apply rules to those events. And rules are matching incoming events and routing them to the targets for processing. You can define, first things first, you can route multiple targets and they will be processed in parallel. So that's a first benefit. And similarity to Amazon SNS. We will talk a little in a moment how to separate those services. There is no defined execution order for rules. So if we have multiple targets and we are processing them in parallel, there is no guaranteed order of execution there. You need to remember that because that sounds like a pitfall in the first place. Additionally, rule can customize the payload, the JSON that will be sent to the target. And if you can pass only the certain parts and override it with the constant. So you can actually rewrite the payload based on your needs and based on your rules. When you create a rule, you associate that rule with a specific event bus, and it matches only the events that are published there. So rules are actually an attribute of an event bus. They're associated with event buses. And rules can be scheduled because we can support both. We can have rate-like expressions and cron-like expressions. And that's the similarity with Amazon CloudWatch events. For those of you who haven't used that service, that was basically our ability to create scheduled triggers for our AWS Lambdas. And you can also schedule those triggers based on the cron-like expressions or rate-like expressions. EventBridge has similar capabilities and works in an exactly the same way, but it is a much bigger service. And actually, CloudWatch events were added to the Amazon CloudWatch because they were added earlier, and there was no such service in the first place that could handle scheduled rules. So that's why they added that in the first place to CloudWatch. But they are actually they want to change this thing, and they want to move those to EventBridge finally as they are actually encouraging everybody to ditch Amazon CloudWatch events in favor, obviously, for EventBridge. And when we have those events on our event bus, they are matched by the rule, we can forward those events to a target. Target is basically something that receives a JSON event and processes it. You can have different integrations, and I listed them later on, but the most important thing that you should remember is that rule target must be in the same region as the rule itself. So that already gives you an interesting view how EventBridge is organized as a service, and we will talk about this later as well. Last but not least, there's a building block called Partner Event Source. It's basically an event source, as the name speaks, that is used by an external AWS partner to send events to any other AWS customer accounts that are subscribed to those events. And to receive those events, the customer must associate the event bus with the partner event source. What are the partners? For example, Datadog, Zendesk, and so on and so on. All those third parties that are external to AWS can actually participate in their program and publish events on the partner event sources. And then if somebody will subscribe to those partner event sources, will receive events to their partner event buses. And that gives you an interesting advantage as a partner and both as a consumer of those services to integrate directly with your application doses. And that gives you actually a tremendous important advantages, because if you are, for example, using Datadog as a service, the other way to implement such integrations was to set up something on your own, and that was cumbersome, and you need to maintain this in the operational way. But thanks to the Amazon EventBridge, and that Datadog actually leverages EventBridge, for example, Datadog, you can actually benefit from the integration without having a third-party code that is polling the service or polling the partner. That is pretty useful and pretty interesting feature. Another building block is Schema Registry. It allows you to discover, create, and manage OpenAPI schemas for events that are published on EventBridge. And you can find schemas for existing AWS services there. You can create and upload your custom schemas and generate a code from the schema. For example, you can generate the client code in Java, in Python, and so on and so on. Speaking about integrations, those are available targets that are available on the AWS side. So you can actually consume events from AWS Lambda, from EC2 instances, from Amazon Kinesis data streams, from Data Firehose. You can actually send events to CloudWatch logs. You can send them to ECS tasks. You can integrate with Systems Manager with run command and automation. You can integrate with batch jobs, step functions. You can trigger pipelines in AWS Code Pipeline. You can trigger builds in Code Build. You can create assessment templates in Amazon Inspector. There are built-in targets for EC2, like create snapshot, reboot instance, stop instance, terminate instance. So there's an easy way to create, for example, a scheduler that will disable all developer instances at the 4 p.m. every day on workdays. You can very easily create such integration on EventBridge. You can actually integrate EventBridge with an EventBridge in a different AWS account. So that gives you an interesting advantage as well to integrate between multiple accounts. And that's how integrations between partner and you also work, because those partners are actually having their infrastructure in AWS. And last but not least, you can also integrate with REST API endpoints in API Gateway. So you can trigger the REST API endpoints that in your API gateways that are defined. So that's a very long list of integrations, but the most interesting things is happening on combining the sources and integrations together. When it comes to the use cases, you can use it in virtually anything that needs Event Bus. So most of the microservice architectures right now are using and can leverage the EventBridge because they are using Event Bus pattern for the communication. All those dots that are listed on the slide, like customer support, security operations, business operations, application monitoring, directory registration, customer data updates, all those dots and all those bullet points have a partner inside Marketplace that is actually handling and integrating as a source. For customer support, it will be Zendesk. For security operations, there is at least 4 different companies that are providing security like features and security like capabilities. For business operations, you've got Salesforce, you've got some CRMs, you've got application monitoring like Datadog. For directory registration, there is Auth0 and so on and so on. For customer data updates, you've got other CRMs as well. So that's a plenty of partners that can integrate with you over those event buses. So this service is really interesting, especially from the partner perspective, but also if you have microservice architectures internally in your company. And that concludes the part 1. So we will move to part 2 in a moment. In the meantime, if you have questions, feel free to drop them in the chat. So I don't see any questions so far. So let's proceed with the next. When it comes to the operational part, first things first, you need to think and talk about high availability. And yeah, EventBridge as a fully managed service has built-in high availability. The only drawback is that you need to take care about disaster recovery for producer and consumer sides. Because EventBridge as a service cannot apply its retry policies. It provides you at least once the content delivery to the target. So that includes the retry with exponential backup up to 24 hours. And well, if events are accepted, they are durably stored across multiple availability zones. So that provides additional assurance for your events that they will be delivered to your destination. Additionally, EventBridge provides 99.9 availability service level agreements, which is pretty standard when it comes to the AWS services. But when it comes to the retries, you need to remember that you need to handle the failure on your site. So for example, if any failure happens, it will retry for 24 hours before marking it as a failed. You can also have dead letter queues and information about the failed invocations. But in case that Lambda, for example, successfully accepts the EventBridge message from the EventBridge perspective, and asynchronously invoke you will invoke asynchronously your function. As long as EventBridge will receive 200 response, from its perspective, is a successful transaction. So if there, from any reason, if there will be a failure in the Lambda execution, you need to retry this on Lambda side. So there is no way to inform EventBridge, please retry it once again to this Lambda because we failed the execution. So keep that in mind and remember that you need to rely on Lambda retry policies or anything else in your application layer if you accepted the message from EventBridge. That's a very important thing. And last but not least, you need to evaluate your needs regarding multi-regional availability, as event buses are bound to a single region anyway. So you can send messages between regions, and you actually can have rules that are associated to event buses, which are regional. But if you need to have multi-regional availability, you need to think about it in the first place. So keep that in mind. When it comes to scalability, it is a fully managed service, so it should seamlessly scale for many consumers without noticing it and without provisioning. However, there are some invocation quotas that are applied by region, and they vary based between 750 and 4,500 requests per second, depending on the most developed regions or less developed regions. So keep that in mind when you will choose the region for your event buses, because that will affect the invocation quotas anyway. After exceeding this limit, events will be delivered, but they may be delayed. So that's the culprit, and that's the problem with the invocation quotas. Speaking about other stuff that are related to operations like pricing, this is truly pay-as-you-go service. So first things first, if you are using AWS service events, those are free. For custom events, for partner events, and cross-account events, we pay $1 for each 1 million of published events. And for events ingest for schema discovery from your schema repository, we pay additionally 10 cents for every million published events. So keep that in mind if you would like to use schema repository, because that will be a little bit more expensive than the usual published of events. It's not a lot, but it may add up when if you are using and actually if you are publishing a lot of events. When it comes to security, Amazon EventBridge supports full encryption in transit via SSL TLS. The same goes with the authentication layer, because it uses signature for the authentication like it uses with anything that actually is on the AWS SDK side. Additionally, we can leverage VPC endpoints to avoid internet communication over the public internet. So that's a good part. The bad part is actually that there is no support for KMS-based server-side encryption for now. And that's a bummer. I don't know how it happened that it has high PA compliance or PCI DSS compliance in such case. But AWS claims that they are managing the encryption keys and they are encrypting the storage on their side, but you don't have any ability to create your own KMS-based server-side encryption keys. So keep that in mind. Okay, so regarding the operational part, we are also pretty much covered. It's not a lot because we are having fully managed service here, so that's the reason why it took so it was so short. But that is actually in most cases a situation with the fully managed services. So do you have any other questions regarding the operational part before we move to the best practices? Okay, so far so good. So we can move to the best practices then. First things first, let's talk about differences between the services, and that's a big thing, because EventBridge and on the surface at least looks very similar to at least two services. First things first, EventBridge versus SNS. Those two services looks a little bit similar when it comes to the notifications and publish subscribe pattern, but EventBridge is recommended if you would like to build application that reacts to events from SaaS applications or AWS services, and if you need content-based filtering capabilities, because it allows you to have any filtering rules that are employed on the content and on the payload as well. So they are not limited like the SNS to just attribute-based filtering. From the other hand, you should use SNS only if you would like to build something that reacts to high throughput and low latency messaging, because SNS has bigger capabilities when it comes to the fan-out patterns, and also to the ability to deliver those such high throughputs and very scalable results in low latency. The truth is that EventBridge is designed to communicate between services, but it wasn't designed in the first place to achieve low latency in fan-out scenarios. And they are mentioning that in the documentation. So keep that in mind. And last but not least, if you need filtering and you can deal with attribute-based filtering, SNS is fine. But if you need content-based filtering, and you can actually apply filtering rules to any field that appears in your payload, then EventBridge is the way to go. When it comes to differences between EventBridge and SQS, situation is much simpler, because SQS is recommended when you want to build applications that need queuing capabilities with durable storage and ability to store those events in the queues for longer periods, like up to 14 days when it comes to retention period for SQS. But if you would like to have an application that reacts to events from external third parties, you don't require buffering and durability, yeah, EventBridge is the way to go. So this distinction is much clearer here. When it comes to Amazon MQ and Amazon EventBridge, that's even more easier distinction and more visible distinction. So EventBridge is recommended for cloud native applications, and if you are building those applications from the ground up, and you don't have any messaging or event bus already existing in your project. From the other hand, if you would like to leverage an existing message broker, you don't want to rewrite your applications, and you need topics and publish subscribe capabilities, then Amazon MQ is the way to go. And it's basically constant, as we talked about it during the Amazon MQ episode, when we described that Amazon MQ is designed for hybrid cloud scenarios. It's basically the same case here. EventBridge is designed for cloud native, and from the applications that we are building from the ground up, for the green field, and Amazon MQ is for handling hybrid cloud scenarios and having an existing message brokers. If you have those, yeah, that's the way to go. Amazon MQ will be your friend. And last but not least, the most confused service with Amazon EventBridge, Kinesis data streams. If you need to have ability to have messages routing or filtering capabilities and unlimited consumer fan out without the need for buffering and persistence, EventBridge is the way to go. Kinesis data streams is basically a durable event log, and you need to use KDS if you need buffering capabilities, and your consumers can deal on your own with shared throughput and filtering messages that they don't need, because they will be replayed in the same order to all consumers anyway. So consumers need to throw out messages that they are not interested in. On the EventBridge side, the story is different. We are using routing and filtering to actually forward those messages to the targets that are interesting in that particular message. So the routing and targeting is the emphasis on routing and targeting is put in a different place. In KDS, it's done on the application side, and in EventBridge, we are using that inside the service when we are defining the rules. So that's the main distinction between those two services. And the situation is even simpler if you need buffering, because EventBridge does not provide you any additional buffering and persistence. If you need such thing, KDS is the way to go. Is that clear so far? So I hope that the distinction between those five services, is clear. and you should know how to use and when to use each of those. If something is not clear, please let me know in the chat, and we will move forward to a next best practice that is related with Schema Registry. As I said in the building blocks part, Schema Registry is the integral part of Amazon EventBridge, and that's a great thing because you can actually have a single place for storing your schemas that are stored out of the band when it comes to the communication and sent events. It additionally helps you with validation and eliminating erroneous cases. But the most powerful thing is when you can generate clients and code bindings in order to speed up development, and that includes the integration with AWS Serverless application model as well. So it's very easy to create your own lambdas that are consuming even the custom messages or partner messages that are sent to the event buses. So you can actually generate a skeleton, application skeleton that will accept your custom events without any coding needed, based just on the schema registry. And that's a pretty cool thing to have, in my opinion. Additionally, another superpower related with EventBridge is ability to exchange events between AWS accounts. And if you will think about it, that's how partners operate between AWS, you, and them, because they are actually having their services available in a different AWS account. They are integrating and registering inside AWS EventBridge partner program, and they are sending events from their accounts to the partner event buses that are subscribed on their events. But you don't have to subscribe to the partner program to leverage the ability to send and exchange events between AWS accounts. So for example, if you have an organization, the AWS organization, that has multiple accounts, and those accounts are separated, but still you would like to leverage and react to some events that are happening in a different account, EventBridge will be a default way to go, because it will be the simplest way to set up this reliably between the accounts inside an organization. So you can actually have a dedicated account, for example, for your business applications and for the data analysts. And each time that something happens in the business application, you can react inside the business analysts application side inside a different account if you will combine and connect those two accounts together via EventBridge. And that's pretty cool power to have. So I definitely recommend to check this out, because that gives you a tremendous opportunity to integrate and separate concerns between the accounts. And last but not least, I would like to talk about the centralized event bus pattern. If you use the custom events inside the Amazon EventBridge, you can actually leverage rules and routing in order to simplify your applications. Here's a great example from the AWS blog post that shows you that there are some ATM transaction events that lands into a custom event bus inside EventBridge. And then based on the list of the rules, we are actually separating the execution of downstream AWS Lambda functions based on those rules inside. Those rules are basically the definitions, JSON definitions that are explaining what should happen in order to transform and route this particular message to this particular AWS function or to the other target. And you are explaining that in a very simple JSON file, rules file, and thanks to that, you can actually forward those rules to appropriate Lambda functions. How the simplification looks like, because on this example, it's already simplified and it may not be visible. Let's talk about this particular centralized event bus pattern. So here you've got an example when we don't have EventBridge and you need to actually implement everything on your own. So first things first, we've got the centralized documents bucket, which generates the custom events from S3. For every single file uploaded there, we are generating 3 different events, and based on the post suffix on those events, we either invoke those one of those 3 lambdas. One of those lambdas is actually using the external service, and then we are basically sending extracted text to a staging bucket or directly to a queued bucket. This is here you have an additional lambda that split the files to smaller things, and here's the lambda that adds those texts to SQSQ. You need to split those files in order to support SQSQ limits. So remember that SQSQ has a limit of 256 kilobytes of the payload. So you need to actually do a lot of work in order to unify those 3 types of documents, processing of those 3 types of documents. And last but not least, we are consuming from SQSQ as a last lambda. We actually consume the content from SQSQ and send that to Amazon Comprehend and extract the entities inside the text, and then send those metadata to Elasticsearch service to further analysis. And if you are familiar with serverless architecture, that's the usual way to see and observe those architectures. But this can be simplified in a more predictable way. For example, if we will use EventBridge and Centralized Event Bus, we can actually publish events in from those lambdas, and instead of connecting together different lambdas by those relations, like here when we are doing the hardwired integrations and hardwired dependencies, we can actually publish an event that will be received by a target on the other side and then processed by someone who doesn't really care who sent event in the first place. The event itself is more important. How does it look like? So in this particular examples, we can have Amazon S3 source buckets like in the previous example. So here's the first change. We can actually have staging buckets, queue buckets, and documents buckets in the first place. Those generate events that are landing on a custom event bus inside EventBridge. And then we've got parser functions, converter functions, analyzer functions, and loader functions that are using different capabilities and different operations to handle different events. So for example, we can have an event that, like in the first place, extracted text from PDF. That will be a parser function. And this event, we can actually subscribe on the custom events from S3 from this particular bucket. And this function for PDFs will subscribe on those events in the first place. If we will upload the JPEG, for example, and we would like to do Amazon recognition, different parser function will subscribe on that and extract the text with use of Amazon recognition. Then from other events that are in the different Amazon S3 bucket, converter functions will kick in. Those converter functions are basically split files and adding SQS to the queue. The same goes with analyzer functions and loader functions. Loader function is the last one that actually push the metadata to the Elasticsearch service, and analyze is actually the Amazon Comprehend integration that extracts entities from the text. So we can actually move the dependencies to an event bus instead of hardwiring them inside applications. That's pretty cool because now analyzer don't have to know where to put the metadata. It just exports the metadata into an event bus, and then loader function knows what to do with that metadata and send it to Elasticsearch service, for example. If we would like to send data to Amazon Elasticsearch service and Redshift, for example, our goal will be to add just another loader function inside the and subscribe to those particular events, and they will be invoked in parallel to handle the separation of concerns. In the previous example, if you would like to add Redshift, we need to add additional implementation layer inside our analyze function, add the Redshift here, and that will complicate the implementation, make it more error prone, less resilient, because you need to handle failures in both channels, maybe retries, and so on and so on. That will be much more problematic when it comes to the software development / troubleshooting. In this case, separation of concerns actually helps us and provides you a much more benefit. And last but not least, when it comes to the centralized event bus pattern, you can actually leverage this thing when it comes to the integration with the externals and third parties. Here you've got an example of the application that reacts to all events that are coming from Auth0, and then saves those events into an S3 bucket to visualize them in the Amazon QuickSight dashboard. And you can subscribe to all events that happens in Auth0, route them properly with the rule engine on the Amazon EventBridge side to different AWS Lambdas, which will extract the proper payload, save it in the unified way inside an S3 bucket, and then inside S3 bucket, we can actually connect the QuickSight to S3 bucket to visualize all those events. Here on the slide, you can see that we are matching the three different events happening on Auth0 side: unsuccessful sign-in, successful sign-in, and successful sign-outs. So that gives you very interesting opportunities when it comes to the integration with the external third parties, to separate concern between the event producers and consumers, and to actually have the routing and filtering part done on the service side, not inside your application. So that's a pretty powerful way to handle this. So that's everything what I prepared for today. So if there are any questions, I will happily answer them. I hope there are some. So I'm waiting for questions. And in the meantime, if there will be no, so Andrew mentioned that nicely explained, but required re-examination at least once after. Yeah, I totally understand that it may be a little bit overwhelming because it was fast-paced and a lot of informations. When it comes to the further plan and future episodes, the next one will be about Apache Kafka, so MSK, Managed Streaming for Kafka on AWS. And next one is about IoT Message Broker. So those two episodes are already planned. They will be scheduled week after week. And hopefully I will see all of you on 11th. I hope so. Are there any other questions so far? Only Andre is not shy right now. Okay, 3, 2, 1. So that's it. Thank you very much. Thanks for the participations. Thanks for being here, and I hopefully we'll see each other in next week. So stay safe and see you soon. Goodbye.